Good afternoon again. Good afternoon. Battery down हो गया? Okay. Today this is very interesting topic. Uh, Liquid cooling. So when we talk about liquid cooling, this is something which is not a new technology. I have seen such technologies deployed even 25 years back, and even before that, in 90s also, when IBM used to sell mainframe, some few hardwares, we used to come with liquid cooling kind of applications. Obviously, there has been a major change in dynamics, a major change in the technology and its application, adaptation, and that's how we are talking about AI and ML. Why we are talking so much about it? Because it consumes a lot of CPU space, and that's how, if you are able to compute more within the limited space, the amount of heat which is generated by the processors are huge, and you require to cool. So obviously, when we require to cool, as of now, we have been using air-cooled technology across in the data centers, and I would say 99.9% of our data centers, and even across the globe, data centers are based on air-cooled technology. And in air-cooled also, there are different technology. I don't want to get into it. We'll focus more on the liquid technology only. So on the liquid technology aspect of it, and with the AI, before I move into the discussions, I would like to have a brief introduction of our esteemed panelists, and then we'll get into the discussion aspect of it.
Yeah, so I'll start from this side, it's more better, yeah. Myself, Yogendra Mandavkar. I am coming from Digital Connections. I'm a solution architect and been working in this industry for the last 20 years with most of the data center companies and all. So that's it for now.
Good evening. This is Rakesh Mishra, and I had the design engineering group for the Techno digital group. And so we have coming up with a lot of data centers. One in Chennai is already getting commissioned, and there are plenty more coming in all over India. That's all.
Good evening all, I'm Manoj Semwal. I'm from Equinix. I take care of the design for Equinix in APAC region. Presently we have around 4 data centers in India, and we'll be constructing more going ahead. Yeah, thank you.
Thank you. So the question is, we have been seeing the technology trends in the past. We saw cloud technology trends way back in 2008, 2009, where people were talking, we are listening in one of the event. We were there, and there were a lot of presentation on cloud. So one of the audience asked, sir, throughout the day, I have listened all this discussion on cloud, but where is rain? There was no rain at the time. But if you look at in 2008 or 2009, we did not see the rain, but we started seeing the rain after 2015. And now that rain has become so huge that it has transformed into the AI kind of application which is the trending now. Even if it is on the nascent stage, I would like to ask Yogendra in terms of how do you see the adaptation of the cooling technology for the AI, and which cooling technology you see, because you have been also looking at a different aspect on the data center front. Yeah. So how do you see to support such kind of application on the cooling part?
So you're asking 2 questions, like the adaptations of AI, the cooling technology for the AI and ML, and which type of cooling technology is what you're asking together. Yes. So the first one is, like, we already started saying that liquid cooling has been used probably for since years and all. You would understand when you are talking about air cooling, you had cold aisle and the hot aisle, and this were the demarcations. Why? Because the cooling in the data center was supposed to be taken in a sense where your power utilization has to be reduced. Now, liquid cooling also focuses on the same thing, the power utilization. The PUE, what we talk about nowadays, is being to be reduced or to be looked into for reduction. Why? Because with the liquid cooling, the power is lesser. This gives you an enhancement of the sustainability. Naturally, the company who's doing this will have a carbon footprints. They will have the ESG standards rates high. And that's how we see that the AI and machine learning will acquire more of density of things coming in, and liquid cooling will support for making it more cooler. Now, what are the technologies which you are saying? Now, in liquid cooling, we have like direct to chip liquid cooling, then we have immersions, and we also have a rear door exchange heaters and all. Okay, so it depends on what type of the data center operators are having, and they can do the retrofit, or they have to go through the greenfield or brownfield. This depends on how it is, so that things and that consideration has to be taken up, and then only we can put up a choice to that question, So that's what I would answer. Manoj and Rakesh can add if something like that.
Okay, I will ask subsequent questions. Before that, I just wanted to ask you, liquid cooling is undeniable, you can't survive without it, or you have options?
So when we started with data centers, when you would have seen way back 20, 30 years back, when people were looking for more data and they started consolidating the data and the data centers out here. Naturally, this part of the position was more. Like I am coming from, we were just talking. So when you feel hot, what do? You have air and the fan, but you go and have a bath. That's my liquid cooling for me, I'm sitting in my office, the ACs are not working, I just tap out on my neck with a cold hand, and I'm liquid cooled. So I'll take this. Why? Because I'm more core to this ground. Yoga is one of my other life, and and that's how I take. So talking technology is what? The technology comes from where we live, what the culture is, and it is undeniable. It will have. The only sense of looking out now is that currently the market, the environments are not likewise. Maybe the customer and the data center operators have to work out, as well as the OEMs and the people in the regulatory have to come together, and that's how we can progress more.
So you were saying liquid cooling is undeniable, the way the processing densities are happening in the data center. That's what you were trying to tell. So that throws another challenge. Because if this is the case, where liquid cooling is taking as mainstream in the data center, so as of now, which is dominated by the air-cooled system, and we have already around 1000 megawatt installed capacity in India, a data center, which is on air-cooled, right? So when we talk about getting the cooling technology transformed into liquid, because the demands and the power densities are going to increase, the processings are going to be different. Obviously, there will be a transformation on the deployment side also, what it needed. So obviously, currently what we are talking about mostly is the greenfield side, where people plan for liquid cooling, it is very easy and do it. But at the same time, how do you leverage the existing data center which has been built already? And if you want to transform such thing and leverage those existing infrastructure, and you want to use the liquid technology in that, so how do you do, how challenging and how easy that thing to take care of?
See, the first thing, when we see about the how you use it, see, there are two ways. If you have existing data center which you have the space allocated for the conventional racks, where it is done by air-cooled systems. Now, if you want to retrofit those kind of racks, there are a lot of challenges here, because you have to see, how the racks compatibility will be there for any kind of these emerging cooling systems, like, it's going to be RDHX, the rear door exchanger, or maybe the D2C, direct to the chip. So everything has to be evaluated first. The planning has to be done, whether you can do it or not. And then you should adopt the right technology to see that you have the right thing, for your system. Because, you have to see that systems has to run for years and years to come. You cannot change after certain years, or because, I mean, you cannot have this shutdown, I mean, taken for any client. And that's important to see that, I mean, things go running, I mean, on and on for years and years. So it's very important to have the planning right on the first place. So for that, I mean, the evaluation has to be done. And the rack is the first one which pros some challenges. The other one is the space. Sorry. You had another challenge. Okay, thank you. So I was talking about the second one, the space challenge. So if you have populated the conventional racks, now if you want to take certain racks and then push in, I mean, the new racks to be compatible with the RDHX or your D2C kind of cooling, I mean, that will be creating a lot of issues here, because, I mean, that may not be suitable for you to get these things changed. So idea is to see that, I mean, based on the kilowatt rating, what you have requirement, you have to choose the right type of cooling. Like RDHX, if you see, I mean, that is fit for around 40 to 45 kind of kilowatt of cooling requirement. Beyond that, I mean, you have to go for certain more advanced technology like the synthetic oil or the dielectric kind of cooling, which is more meant for the 100 kilowatt range kind of. So space is there, then the rack is there. And again, I mean, if I have to see the retrofitting, now there are challenges on the power side also. Now, if you have already drawn your power system, the electrical power system, now it is meant for your conventional cooling racks, then it will pose challenge to have the higher density racks, which has this RDHX or the D2C coolants. So if your systems are okay, like I tell you an example, I mean, we have our data center in Chennai. So that has been made so flexible that, I mean, it can take any kind of cooling requirement. So our system structure, infrastructure, what we have created, it can have any conventional racks, or maybe have all this new racks which are coming, which has all those GPUs and which is meant for AI ML. So here, the major part of the electrical power system is that, I mean, your capacity or the distribution, what you have taken, I mean, that should be capable of, I mean, achieving this target. The other advantage, what I see in this is the space. Like, I mean, if you have the higher wattage, imagine if I take this example of the data hall, which I have. This is meant for 3 megawatt, I can say. Now, in 3 megawatt, I have around 300 racks. Now, the moment I go with the 45 kilowatt rack, I have a huge saving on the space. A huge saving. The only thing is, I mean, you have to see that your electrical power is consumed fully. But when it comes to the space, the white space area, you save a lot. So that will come to later on how the TCO works or the ROI works on this. But retrofitting for the new systems, I mean, that can be easily done. So challenges are always there. So you take any retrofitting work, be it or any non-work also, you will see challenges always there. So ways, and being what are we for?
So, if you look at from my perspective also, my view is the data center which has already been fitted out, which is live. Retrofitting those area would be much difficult. I cannot say yes or no as of now. We need to do real research and then find out. But on the face of it, it is very difficult, very difficult to do the retrofit and fit in. Almost you have to remove everything and then you have to do it. So how does it make sense in terms of whenever you do investment versus return on that part of it? Point number one. Point number two, as you rightly said, when you build a data center, you plan for certain capacity, you occupy floor wise. The floors which has not been occupied, you want to put it for a kind of a liquid cooling. You can do some kind of modification at the back end and you can do that, right? Now coming back to Semwal, what I am talking about is this technology is now being adapted fast for AI applications, and which is very crucial also. It may be another big fire safety problems too, because you are putting 100, 200 kilowatt per rack in a single rack, heat. So in that scenario, do you see any regulatory kind of framework which is available and it goes through and ensure that all those compliances and requirement or objectives are met?
Sure. So for now, I don't see any regulatory things available for these kind of liquid cooling stuffs. But yes, definitely these regulatory things would be required to get India into the AI ready kind of framework, right? So why this is required? I would say the first thing is that sustainability and the energy efficiency is becoming a priority of our country. Not only our country, but yeah, it's other countries are already deploying it, right? So if you talk about Singapore, if you talk about US, Singapore, the IMDA department, they are already into it. They are already defining the PUEs. They are already defining the PUEs as low as 1.2 and 1.3 kind of stuff, right? So those regulatories are required. And when it comes to energy efficiency, liquid cooling offers, I think, nearly around 30 to 40% more efficient than the air-cooled servers because of the reduction in the power requirement for those fan units and all. Fan units, when I say fan units, the fans which are present in the servers. That is on the energy efficiency part. Second thing on the cost. So deploying a liquid cooling system itself is very costly affair for now in India because of these costly equipment what we have in the CDUs, then the piping, then the manifolds and all those stuff. So the regulatory would be required over here in terms of, I would say, subsidies like the same way we have it, we had it for the solar panels, right? So similarly, the subsidies would be beneficial if we get it in the CDUs and the other stuffs like that. The subsidies in terms of land, of course, because India specifically, if you see, all our data centers are consolidated or skewed towards the major cities like Mumbai, Chennai, Delhi, Bangalore, which are like, the land cost itself is very costly. So unlike the other countries where they can deploy the data centers anywhere in their region because they have the power and network availability over there. But since we don't have that, so yes, the subsidies in the land would be a beneficial stuff. Then yes, I mean, this is about like, taking it from the government. Now giving it back also comes into picture, getting a better PUE out of these liquid cooling servers. Over here, I would I would not talk about the PUE NK. It would be rather than PUE, it would be a TUE. I spoke about this TUE in another session in the afternoon. So TUE is nothing but the total usage effectiveness, which considers the power consumption by the fans in the servers and all. So if you look at the air-cooled servers, we consider those power consumption by those fans and all inside the IT capacity. So the IT goes up, and but however, in the liquid cooling stuff, the computing goes up with the same kind of power. So yes, in terms of the government subsidies and the authority requirements, yes, we would be looking forward for it. And yes, I think we are still lagging behind compared to the other countries. So that is the need of the hour, I would say.
Yeah, I agree with you in terms of adaptability on the AI front or the liquid cooling. We are at a nascent stage, and it has to mature. But looking at the advantage of the liquid cooling overall, if you see on the data center perspective, one of the reason is PUE and all, and also the space what is required to do that. Overall, then days are not far when liquid cooling will be on the mainstream, and the air cool may be the supplementary one. So at the time, obviously there are a lot of dependency. It is not only on the facility side, it is also depends on the hardware size of it, which has to support, because it is a kind of a integration which we do. So coming back to the next question to Yogendra, in terms of, this is for the people to know the basic question. So obviously the liquid cooling comes under two stuff. One is immersion cooling, another is direct to chip cooling. So this is very confusing, right? Which cooling to select? What is the right solution for a specific requirement which customers should look at? So can you be able to just throw some light and
Yeah,
provide
so
some differentiation?
we need to look, or the customer or the data center operators as in community need to look, how are we starting and where are we starting. So if it is a greenfield project, naturally people should start with the DLC, the direct to chip, because your design for the data center has to be not only the power and the space and all stuff, but your rack, which goes from 8 kilowatt to around about 150 kilowatt of density to be using. Naturally, the load bearing, what do you mean by the load bearing, is the weight of that floor is going to increase. And if that is not being looked into during the building stage itself, when the data center building is coming up, you're not at all going to be eligible to do the liquid cooling part, because these are the machines, these are the hardcore metal which has to go in there. But yeah, there are people who are into brownfield where they still need the high density and already the data center is there, and we need to do. So what we do in my side, like I'm coming from Digital Connexion, already said, the parent company is Digital Reality, which has 300 data center across the globe. And we have these things out of India. So my first data center in India is in Chennai, Ambattur. So there we have already done this. But what I'm talking here is about brownfield. In the brownfield, you can use a modular design where you can have the rear door heat exchangers into it, and also look into it where the direct to chip cooling can be effectively used. Why? Because we do the 80-20% of requirement, where 80% can be done by the liquid cooling through the chillers and all, 20% can be taken up by the air. So these are the combinations and equations which one, as an engineer, Rakesh already said, need to fit and set. You cannot do 2 plus 2, 4, and 2 2s are 4. So that's a good equation, but then you have to see how and what you're adding or you're multiplying. When the digits go high, the addition doesn't make sense, the multiplication goes high, So these are the things which one should understand, and this is where an engineer or a solution architect comes into picture, and he then guides you about it. That's where I would say.
Great, Yogendra. One of the things I have observed in liquid cooling, and while typical tier certification process, so I'm not exactly talking about tier certification. Why I'm highlighting is how resilient or reliable this liquid cooling system is, how easy to maintain, how or any specific thing which is required to be done. Because what I heard from Uptime is they are not certifying liquid cooling as a part of certification program. That means even tier 3 they are not certifying. That means the overall system on the liquid cooling is not concurrently maintainable. So that is a big question mark in terms of how do we ensure that even if we are deploying such technology and we have the system at least which is concurrently maintainable. So can we be able to throw some light?
Yeah, this is really a
Rakesh.
challenging thing on the certification part. So what it boils down to us only. I mean, how you see the concurrent maintainability is achieved. So for that thing, I mean, we have to see all the basic fundamentals we are using it. So it's all about the redundancy. And based on that, we have to see that what all components we are adding in this new futuristic cooling system, what resilience and the redundancy we have to use at each component level or each path level we have. So like, I mean, we take the case of CDUs or the pumps or the piping system, maybe some headers we can throw. So we have to see that at every consequential situation, I mean, then what we have to see that your system is running perfectly. Like if something is going down, is under breakdown, or maybe a failure is there, how this is being taken over by the other system. Like we see the fundamentally in the other things, like whether it's going to be electrical or it's going to be chiller system. So for that reason, we had to evaluate yourself that, I mean, if you have the situation at any point, the failure is there, what is the outcome? So you have to test all this yourself, because as you said rightly, I mean, you do not have any standards to test, I mean, these new technologies. And that is why, I mean, you said rightly, this is not being adopted so frequently. That is why this inhibition is there. People are paranoid to accept this. So we have to see that, I mean, how we get the confidence within self, and then you see that all the certification people adopt this. it's very important that, I mean, you
Just
first check
follow-
it.
Yeah, just a follow-up question also to you, or you can also answer. Is how do we select? I have not got the clarity in terms of immersion versus direct to chip. How do I select?
So maybe I can answer this. So this is basically for the customers who are the end users, right? So still I would say, at least in India, there is a perception developed for the immersed cooling, right? So still people are not so comfortable in dipping their servers inside a liquid, I would say. So that's actually a perception. However, if you talk about the technology, if you talk about the engineering, yes, the immersion-based liquid cooling is more efficient compared to the direct-to-chip, because if you look at the direct-to-chip cooling, it would cool maximum up to the most efficient. What I have seen is like 90% efficiency what they provide in terms of liquid cooling, and rest of the 10% is rejected into the room, and then we'll have to cool that additional heat with respect to the peripheral units and all. Whereas in immersion cooling, it's not the case. You just have to give the room cooling and all those stuff. So that's actually a customer perception what they have to still develop in the country.
But it also depends on the hardware, right?
Absolutely.
If hardware doesn't support direct to chip, then you cannot deploy, right?
So just
but
to add
immersion
on,
cooling can.
yeah, so just to add on Sir's answer on the retrofitting part, right? So retrofitting would be, I would say it is easier to do in the direct-to-chip liquid cooling as compared to the immersion, because immersion type of liquid cooling would require specific hardwares which should be manufactured for that application, whereas the existing air-cooled servers can also be retrofitted for a direct-to-chip cooling.
But there has to be a space to put the heat sink and all those stuff, right? Cold plate. Unless and until there is no space, how do you put it in the existing servers? Because blade servers are so thin.
I agree, absolutely,
Right?
absolutely. So at the same time, when we talk about this space, the server which was like emitting a heat of, or was designed for 10 kilowatt, would be now having a 15 or 20 kilowatt. So we are densing it up basically. And yes, from the space perspective, the CDUs needs to be placed as well. That's another challenge.
My last question to all three of you can answer one by one. Just short, because she said 5 minutes. I can ask for another 5 minutes for Q&A, right? Okay. So, as of now, I know this is a very short time to say what is the learning and all the stuff which is coming. But both of you are already seen the systems deployed out of India for a lot more time. So what is the learning which you have got, and you would like to use that as a part of improvement in our part of the world?
So as far as learning is concerned, first of all, I won't say that for liquid cooling, as far as the technology is concerned, India is lagging behind. I won't say that. Yes, we do have lesser volume in terms of.
I'm not saying it is lagging behind. The question is, obviously, early there has been the first. So there has already been in the Western countries. They were already been deployed for a couple of months or years together. So there, if you have got some learning, at least such thing you can be able to incorporate in our part of the world.
Yeah. So so if I talk about the technology per se, so their deployment is what I have seen in the other part of the country is they have deployed the liquid cooling along with the air side cooling as well. So the air cooled servers and the liquid cooling servers, they generally put it in the same data hall, so that any uncertainty in terms of the customer requirement that can be taken care of. The second thing is again emphasizing on the energy efficiency part of it and the sustainability. So those countries, especially the US and the European nations, so they are more emphasizing on the energy efficiency part of it. I mean, they are anyways leveraging on the climatic conditions as well, but yes, for the tropical countries, like us, so we would be like, you know, benefiting out of those liquid cooling in terms of the efficiency by having the higher chill water temperature. So these higher chill water temperature is what we have seen that in the European or in the Western countries, they have adopted it earlier than us. So we are still talking about like what 22 degrees Celsius, so they have already reached beyond that. So that is one of the things. Second would be, I would say, the manufacturing, the local manufacturing. Those countries, especially for the data center applications, they have the local manufacturing available for these liquid cooling stuffs, especially on the CDUs and the manifolds and the negative pressure pipings and all those stuff. So the ecosystem is already developed, and we are yet to develop that ecosystem.
Thanks. Yogendra, just...
Yeah, so he has answered a lot of things, but what I would rather say that India has been on, if you see the growth, what in last 70 years and all also, we are far more better than any other third world company or country itself. What I see here is the learning is already we take it from the other countries like what he has said, Singapore, US and Europe and all. We do have data centers which are there. The best thing to do start is training the people staff, the standard operating procedures and all. And when these are in the places, we are not left behind. It can happen very fast. Today also, in our data center, we have seen that these things are there. We need to see that the backup and the people are coming in. So your process, the technology and the people have to be come together. And that's what the learning we have already. So we are there and we'll be doing this more better.
Okay, thanks. Rakesh, any inputs?
Yeah, nothing more, but I would say that, see, you cannot learn anything until you use it. I mean, see, we have been using all those air cooling for so many years. We learned a lot. I mean, so it wasn't a simple thing. I mean, every project if you go into, I mean, you learn new thing every time. So similarly here also, you have to use these liquid coolings to see that, I mean, what learning you can achieve more when you start using it. And for that reason, coming from the various companies, we have to take a step forward to see that, I mean, we use it firmly. So when you take more step forward to yourself, and then you see the people, I mean, outside who are from OEMs or maybe from client, they will be also taking a step. See, unless you create a volume to have the business, I mean, you cannot grow fastly, because if you see, compare the cost of all these, what we are talking about, like D2C, I mean, all this cooling system is 5 times compared to the RDHX system. And if I compare with air cooling, it goes to around 7 times. So this has to be reduced, see, because cost is a major factor here. Until and unless we reduce the cost, I mean, we cannot adopt it. Okay. So that's the only way, I mean, we have to take forward the whole journey together. We take a step, you also take a step, simple.
So thanks. To summarize the entire discussion, I would like to say point number 1, liquid cooling is something, even if it is on the nascent stage, adaptation is on, and it is like rain of the cloud discussions what we were doing, and this is going to take the shape, and there is no research I have done, but as for whatever inputs I have gone and study which I have done based on internet, 5 or 6 years down the line, we are going to see this technology dominating in the data center. Obviously, there has been a lot of advantages as they stage, because that is the technology which can give you PUE of 1.2, and we are talking now maybe with upgradation or change in the technology, we may be able to improve further. Third part, as of now, there has not been any specific standard or specific policy around liquid technologies. Maybe with this process of adaptation, that will also come into the picture to ensure that whatever technology is being deployed and done is of certain benchmarks which is being complied with. Third is obviously last, which we are talking about, which we raised the question mark on the resiliency of this technology. Obviously, this is a very small thing, and solution will come where we are not going to talk about concurrent maintainable, but we may be able to talk about fault tolerant data centers on liquid cooling. So with this, I would like to thank all of you, and if I have got time to take one or two questions. Yeah. So one questions from audience, if there is any.
When adapting these cooling technologies and when we grow our AI computation power, so how are we just like when looking into the waters, is it going to create any scarcity of water or anything like what when we had a like fire in US, like there was a news like because of the AI data centers there was some water scarcity. So any view on that?
The question is on the
Or-
water
or-
scarcity.
Yeah, or like what I read was AI data centers are very thirsty. So when you adapt these technologies and when you grow your computation power, what is your view on this water, this headlines?
So in terms of water, if you say, first of all, India is a water scarce country, I would say, right? So we don't use the water cooled chillers anymore. So all the chillers what we use are air cooled chillers. That is one. These liquid cool servers can also be deployed with the air cooled servers. So in the other countries, if I take an example, the chillers can be completely eliminated and we can directly work on the cooling towers where the water requirement is there. But over here with the air cooled chillers, it's again a closed loop system. Water requirement would be there, but at the first fill only. Later on, a minor top up would be required. Otherwise, it's again a closed loop system.
Hello. Yeah, let me add another thing also. Like, I mean, when it comes to the water crisis, I mean, what we are using for the cooling system. See, we have plenty of technologies, like we have cooling towers, which are adiabatic cooling towers, which we use only 1/5 of the water content as compared to the conventional cooling towers. So this is one. Now, when we are talking about all this immersion cooling, now we have a different technology. Water will not be used at all. I mean, it's going to be all the dielectric. Although dielectric is very costly, but in terms of water saving, I mean, this is nothing.
Yes, sir, please go ahead.
Yeah. Hi. This question is to Mr. Manoj. So you mentioned TEU, total effective utilization. So there was already a PUE and WUE. What is the what is the significance of this?
So I'll tell you why it's not a confusion, I would say, but yeah, the PUE. If I talk about on one hand I'll take the air cooled servers, right? The traditional air cooled servers. So what's the computing happening in the air cooled servers? So if I talk about 1 kilowatt server unit, the entire 1 kilowatt is going inside the server, right? The computing is X percentage, and the entire 1 kilowatt is again dissipated in terms of heat. Now, out of those 1 kilowatt, there is some portion of power consumption by what? By the fans, right? Apart from the microprocessors, these fans are consuming power, which is again calculated in the IT power, which is not the fact. Fact is that actually the fan power should be removed and then the actual IT should be calculated. But that's not happening. It's very complicated to calculate it in that way, right? Whereas in liquid cooling, if you see in the liquid cooling, we don't have fans. We do have for the direct to chip liquid, but those are very minimal. So the fans power consumption is drastically reduced by 90%, right? So that power is not getting added up in the IT power consumption, whereas that is utilized for the computing application. So that's why the total usage effectiveness comes into picture rather than the PUE. I hope I answered.
So on the lighter side, this is technology, and technology will always use some term which will be very interesting. It is all about actually they are reducing the IT power and taking credit on the facility aspect. So that's the reason we are talking about total power, total utilization. Okay, so with this I would like to conclude this session. I would like to thank my esteemed panelist who has really given very valuable inputs, and I hope those inputs has been available to audience also. And thanks again for patience hearing us and concentration ke saath. So thanks, have a great evening. Take care, enjoy.
Thank you.